All right, so number 3 is kind of a long problem. They're asking us to find the empirical formula. So I put the steps up here that you need to do that. So first, we need to determine the mass of each element. The problem gave us everything in percentages. When it does that, you can go ahead and assume that the percentages are actually grams, because if everything out of 100, everything should be in proportion to each other. So I'm just going to pretend that these say grams. So boom, I did number 1. Number 2 is a little bit long. Convert the mass of each element to moles. So that means I have to convert 24.75 grams of carbon to moles. So I know that the molar mass of carbon is 12.011 grams in 1 mole. This is for carbon. I'm going to do the same for hydrogen. Hopefully I don't run out of room. So I have 2.58 grams of hydrogen. I know that there are 1.008 grams of hydrogen in 1 mole. Alrighty. Then I have nitrogen. So this has a lot of parts. 14.5 grams of nitrogen. I know that there are 14.007 grams of nitrogen in 1 mole. Last but not least, I have oxygen. So let's see if I can fit this in here. I have 58.17 grams of oxygen. I know that there are 15.999 grams of oxygen in 1 mole. So now I can go ahead and do the math for all of these. So 24.75, my grams cancel out. 24.75 divided by 12.011 is about 2.06. 2.56 divided by 1.008, again my grams cancel out, I'm finding my moles, is approximately 1.04. My grams cancel out here again, and I'm left with moles. 14.5 divided by 14.007 is about 1.04. 1.04, wait. 14.007. Backtrack there. 2.56 divided by 1.08 is approximately 2.56 moles. 14.5 divided by 14.007 is approximately 1.04 moles. And last but not least, 58.17 divided by 15.999 is about 3.64 moles. So I converted the mass to moles. I did that. So now I have to find the mole-to-mole ratios for each element. So number 4 says that if these ratios do not turn out to be whole numbers, multiply each ratio by something, but all of these are whole numbers, but they're not like whole numbers. So I am going to approximate this one to 2. I'm going to approximate this one to 3. I'm going to approximate this one to 1. And I'm going to approximate this one to 4. All right, so I did number 3, and I'm just approximating. I'm rounding to wherever number these mole numbers round. Write the formula using the mole ratio as the subscript. So all of these numbers are going to be my subscript. I know that I have carbon in my formula. I know that I have hydrogen in my formula. I know that I have nitrogen in my formula, and I know that I have oxygen in my formula. So for carbon, I got 2. 2 is my moles, so 2 is my subscript. For hydrogen, I got 3. 3 is my moles, so 3 is my hydrogen. For nitrogen, I got 1. Because in chemistry, when you have one atom, you don't write it. I'm just going to leave it there. And for oxygen, I got 4. So that is my empirical formula. I cannot make that any smaller, and I used my mole ratio, all of these numbers, to write it.